In the last video, we discussed shared logs and exclusive logs, as well as how Slack for Share and Slack for Update utilize these logs and their behaviors. If you haven't watched the previous video, I encourage you to do so for a better understanding. In this video, I will cover other types of logs. The concepts are similar to those in my other videos. We will start by reviewing the definition from the docs, and then proceed with some experiments. I believe that by doing so, you will better grasp the points from the document and gain a deeper understanding. Let's get started. Intention log. An intention share log (IS) indicates that a transaction intends to set a share log on individual rows in a table. An intention exclusive log (IX) indicates that the transaction intends to set an exclusive log on individual rows in the table. Slack for Share require an IS log before S log, and Slack for Update require IX log before X log. This screenshot shows log compatibility. Personally, I hardly notice intention log, but I think it's worth knowing about them. Record log. A record log is a log on an index record. I briefly discussed this at the end of last video. If you remember, we used the SQL queries like select star from balance where user ID equals to 3 for share or for updates. Since user ID is an index column, the InnoDB engine can identify this specific row using the index and apply a record log with either an S or X log. I want to show you a piece of log monitor log for record log. Log mode X logs rec but not gap. If you check the doc, the next type of log is a gap log, but I think it will be easier to understand by explaining next key log first. Let's pause on gap logs for now and first explain the next key log. The entire definition is a little bit long and hard to understand. I picked the most important part for you. A next key log is an index record log plus a gap log on the gap preceding the index record. If one session has a shared or exclusive log on the record R in an index, another transaction cannot insert a new index record in the gap immediately before R in the index order. Let's go over some examples to better understand it. Let's continue with the balance table. The ID column is a primary key, and user ID is another index column in this table. First, let's check out the data in this table. InnoDB divides the table into multiple intervals. In our case, the intervals are -infinity to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 10, 10 to infinity. An open bracket means the value is not included, while a closed bracket means the value is included. Now consider a statement like this. The where clause uses the index column. In this case, InnoDB sets an exclusive next key log on all rows where user ID larger than 3, which corresponds to the highlighted area. It also logs a gap preceding the index record, which is a 2 to 3. That means no other concurrent transaction can insert a user ID greater than or equal to 3. User ID 4 cannot be inserted concurrently. User ID 3 cannot be inserted concurrently. However, concurrent transactions can still insert records in other ranges. Let's try another example. This time, consider the following query. In this case, we are not able to insert 10 for sure. Do you think we can insert 9? What about 4 or 3? I encourage you to pause the video a little bit here and think about it. 9 cannot be inserted concurrently. 4 cannot be inserted concurrently. 3 can be inserted. Again, InnoDB sets an exclusive lock on range 4 to infinity, as well as the gap preceding the index record, which is 3 to 4. Any inserts with user ID larger than or equal to 4 cannot be inserted during the execution of key 1. When we use a non-indexed column, such as a mount column, InnoDB cannot use an index to locate specific rows. As a result, it scans all rows in the table and locks all of them. No matter what range we try to insert into the balance table, the insert statements will have to wait until T1 is completed. As you can see, none of the inserts can happen concurrently. When working with row-level logs on non-indexed columns, performance can be significantly affected. If you want to improve the performance, try to add an index on this non-indexed column. For other logs, such as the auto-increment log, if one transaction is inserting values into the table, all other transactions must wait before they can perform their own inserts into the same table. You can read more about this log in the doc. However, I believe it is especially important to understand log I have mentioned above. They are critical to understand MySQL InnoDB engine behaviors. I hope this video helped you gain insights and understand the fundamental of MySQL logs. If you have any questions, feel free to post them in the comments below. Thanks for watching.